Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 11, Part 3, Part 5. Today we're going to talk about limiting factors. So limiting reactants, or you might hear this referred to as limiting reagents. So let's talk about sandwiches. Suppose you want to make 2 ham and cheese sandwiches. And for each ham and cheese sandwich, you're going to need 2 slices of bread, 2 slices of ham, and 1 slice of cheese. So if you want to make 2 of them, you would need 4 slices of bread, 4 slices of ham, 2 slices of cheese. So what happens if we have 4, but 1 slice of cheese? Can we make 2 sandwiches? No. What is our limiting factor? What's our limiting reactant? What's our limiting reagent? The cheese. So it's just like ham and cheese sandwiches, but we're going to have some chemicals and some compounds in there. Please write this down. Usually during a chemical reaction, one of the reactants is limited and there's extra or in excess or more of the other reactants. So the limited reactant determines how much product is made. And it's not necessarily the reactant with the smallest amount. Just because of coefficients and moles and molar masses, elements have different molar masses, it's not always the one with the smallest amount. So let's look at an example of this. If we have 10 grams of hydrogen and we have 20 grams of oxygen, to make water, oxygen is actually the limiting reactant. Why? Well, because oxygen has a much higher molar mass than hydrogen, so there's a lot more moles of hydrogen in 10 grams than there are of oxygen in 20 grams. So, the excess reactant is the reactant that remains after a reaction is complete. So some reactant remains after a reaction is complete. And then the limiting reactant is the one that runs out and limits how much product you can make. Since it limits how much product we can make, and product is what we want, then it's really important to figure out what is the limiting reactant so you can figure out how much product you can make, because that's really important to do. All right, when we are calculating that problem, number 1, write a balanced chemical equation. And then we're going to convert each reactant from mass to mole. So you're going to do a mass to mole conversion and then label that half. So let's say 5 moles water, half. You're going to do that for each of the reactants. And then you're going to pretend all of the reactant reacts, how much of the second reactant would be needed, and label that answer need. And that's going to be a mole-to-mole problem. So this might sound a little confusing, but we'll go through it and it'll make more sense. Next, you're going to compare the calculated amount, the needs, with the actual amounts, the halves. And if the actual amount have is less than the calculated amount need, that is your limiting reactant. So if you need to do this, use the limiting reactant to calculate the amount of product. So if the question asked you to take one more step, then we will do the step 5. All right, so let's do this. Given this equation, 3 moles of solid iron reacts with 4 moles of water vapor to form 1 mole of, this is black iron oxide, and 4 moles of hydrogen gas. So if 36.0 grams of water reacts with 167 grams of iron to produce black iron oxide, and then there's going to be 3 questions. A, which reactant is the limiting reagent or reactant? How much of the excess reagent is used? What is the mass of the product, black iron oxide? So please take a moment and make sure this whole question is written down, and then we will go through it together. So before we get comfortable, make sure you have your periodic table and your calculator. And what we're going to do is we're going to write what we know. So, looking at what we know, I have 36 grams of water and 167 grams of iron. And the first question is, what is the limiting reagent? So, 36.0 grams water and 167 grams iron. And I'm trying to figure out the limiting reagent. Then I'm going to calculate, and we are supposed to write a balanced chemical equation. That one's already given to us, so I'll just rewrite it down here so I don't have to scroll up and back so much. Wonderful. The next thing we're supposed to do is convert each reactant from mass to moles and label the answer have. So it doesn't really matter which one you choose to do first. I'll just choose iron. So I have iron is how much I'm going from mass to moles. Do I use the 3 in the balanced chemical equation? No. I have to start with what I have, 167 grams of iron. 167 grams of iron over 1. And to go from mass to moles, I'm going to need the molar mass of iron, which is on the periodic table. So in 1 mole of iron, it has a mass of, hopefully you wrote it down, 55.85 grams of iron. So my grams iron cancels with my grams iron. I'm left with moles iron. I'm going to grab out my calculator and take 167 divided by 55.85. So please do that. Okay, so you should have an answer, and I got 2.99, and I want to go to 4 sig figs. I'll just, when I'm doing this, let's go to 4 sig figs, 0, and then I'm at moles iron. Alright, so I have to do that to each one. So now let's convert water, the mass of water, into moles. If you remember, there's 36.0 grams of water. 36.0 grams of water, that's my original quantity, over 1 times my conversion factor. In 1 mole of water, I'm going to have to figure out its molar mass. So take a moment and figure out the molar mass of water. Okay, did you figure out it is 18.02 grams? If so, good job. And then we're going to calculate this. Let's double check we set it up correctly, cancel our units. I'm left with moles water. Yep, that's what I want. So 36 divided by 18.02. And what did you get? Rounded to 4 sig figs. I got 1.99 and then 77. So 8 moles H2O. And remember, we're supposed to label these have. And let's also label this one have. All right. Then, for each reactant, we're going to pretend it all reacts and figure out how much of the second reactant would be needed and label that need. So it doesn't really matter which one we pick. Let's pick iron. So 2.990 moles of iron. That's my original quantity, 2.990 moles of iron over 1. And I'm going to see how much, so it's a mole to mole conversion. So to do a mole to mole conversion, I have to look at the balanced chemical equation. So let's look up at the balanced chemical equation. 3 moles of iron and 4 moles of water. I know the 3 moles of iron are going to have to go on the bottom to cancel it out. So that means the 4 moles of water are going to go on the top. I'll cancel my units. I'm left with moles water. Yep, that's what I need to do, is the other reactant. So then I'm going to take this 2.99 times 4 divided by 3. So please do that and get your answer. Okay, what did you get for your answer? If you got 3.98 and then rounding to the nearest sig fig for 4 sig figs, 3.987 moles water. We're supposed to label this need. Good job. Now we have to do that for the other one. So we'll start with how much water we have, which we have to go all the way back up here. How much water do we have? 1.998 moles. So 1.998 moles of water over 1 times my mole ratio, which is going to be the same mole ratio, but we have to flip it. So water is going to be on the bottom. 4 moles H2O over 3 moles iron. All right, so grab out your calculator and do that calculation, please. Did you get your answer? So I got 1.4985. So 4 sig figs would be 9 moles of, well, moles water cancel, so I'm left with moles iron. And that is need. Okay, so now I have numbers. What do I do with them? Let's look up here. Actually, let's look down and then we'll look back up. Compare the calculated amount of each reactant with the actual amount of the reactant. If the actual amount you have is less than what you need, that's your limiting reactant. Okay, so let's look at iron. I have 2.99 moles. I need 1.499 moles. So I have more than I need. Okay, so now let's look at water. I have 1.998 moles of water. I need 3.987. Oh, I don't have enough. So then, what is my limiting reactant? Please write that down. Okay, did you say water? If so, good job. I'll put a box around our answer. And then let's check. All right, so coming up here, all the way up to the top. If I have 36 grams of water, 36 grams, so I have around 2 moles, because the molar mass of water is 18. I have about 2 moles of water. If I have 167 grams of iron, I have about 167, it's about 50, so if we take 150 divided by 50, and I'm rounding these numbers, that would be 3, so I have about 3 moles of iron. So let's look here. If I have 3 at the balanced chemical equation, if I have 3 moles of iron, I'm going to need 4 moles of water. Well, I only have 2, so I'm going to run out of water first. Is that what I found? Yes, water is the limiting reactant. So we got an answer. We answered the question, and it makes sense. Good job. Okay, so we're going to tackle the other parts of the questions, B and C, in our next video. I will see you then. Bye.